Hello students, as we discussed about BFS and DFS in the classroom. So in this video, I will be telling about graph traversal. We have already discussed about tree traversal, pre-order, in-order and post-order. Now in this video, we'll be discussing about BFS and DFS. So first, let us discuss BFS. For that, we'll be taking an example. So let us suppose we are given this graph, and in this graph, we are having some vertices A, B, C, D, and E. So BFS is breadth first search. It uses Q for the implementation. So in the numerical, you will be given a source vertex A, and you have to find out the BFS traversal for it. So once you are given the source vertex, you will be putting all the adjacent vertices to that source vertex. So we can see in this particular graph that we are having B, E, and D as its adjacent vertex for A. So we'll be writing here B, E, and D. Now we have traversed all four vertices. Now the last fifth vertex is left. So we can see that all the adjacent vertices of A has been covered. Now we'll move to all the adjacent vertices of B. So all the adjacent vertices of B are A, E, and C. So A and E are already covered. So we'll be writing here C. So that is the last vertex. So this is our BFS. Now let us write the same traversal in some other order. If we write it like this, instead of BED, if we write in this order, E, B, and D. And the last vertex we are left with is C, and C is also adjacent to E. Another option, another answer for this would be, again, D, E, B. And the adjacent vertex of D is C. So we can write all the combinations of B, E, and D. So the main thing is in BFS, first of all, we take a vertex, a source vertex, and all the adjacent vertices to that vertex. Once all the adjacent vertices to that vertex are covered, we will be taking the next vertex in the queue, and we will be taking the adjacent vertices of that next vertex. Okay, so this is how we have taken the example of DFS. BFS. Now we'll be discussing the example of DFS. First of all, let me remove this. So now we'll be discussing DFS. So again, we are given a source vertex A. Now source vertex A has all three adjacent vertices B, E, and D. So instead of taking all three vertices together, we will be taking a single vertex, either B, either E, or either B. If we have taken B, so now adjacent vertices to B will be taken. That is E, C, and A. So we can take either E, either C, either A. So A is already taken. So next will be E. E has two adjacent vertices, C and D. Another another solution, possible solution for this would be A. Adjacent vertices for A is B, E, and D. So instead of B, we are taking E here. And for E, we are having adjacent vertices B, C, and D. So instead of B, we'll be taking here C. And adjacent vertex for C is B. And another adjacent vertex for C is D. So this is how we can apply DFS over here. So that's it. I hope you have understood this.